Hello friends, welcome to the concrete world. Today we'll discuss how to do mix design using IS code 10262-2019 and IS 456-2000. दोस्तों, मिक्स डिज़ाइन एक कॉम्प्लिकेटेड और लेंथी प्रोसेस है, लेकिन हमने मिक्स डिज़ाइन को 6 सिंपल स्टेप्स में डिवाइड किया है. Step number 1 is target mean strength. Step number 2 is water cement ratio. Step number 3 is water content. Step number 4 is calculation of cement content. Step number 5 is aggregate proportion of coarse aggregate and fine aggregate. And last step is mix calculation. To make it easy, मैं आपको यह मिक्स डिज़ाइन का कैलकुलेशन एक्सेल फॉर्मेट में समझाऊंगा ताकि आप इसे आसानी से समझ सकें. So let's get started and understand how to do mix design of M30 grade of concrete. Mix design करने से पहले आपके पास कुछ डेटा का होना जरूरी है. उस डेटा के बेसिस पर ही आप मिक्स डिजाइन कर सकते हो. डेटा रिक्वायर्ड फॉर मिक्स डिजाइन.
ग्रेड डेजिग्नेशन यानी ग्रेड ऑफ कंक्रीट कौन सा है, M30. टाइप ऑफ सीमेंट OPC 43 ग्रेड. मैक्सिमम नॉमिनल साइज ऑफ एग्रीगेट 20 mm. Minimum cement content 320 kg per meter cube as per IS 456 table number 5. Maximum water cement ratio 0.45. Workability slump required 125 mm. Exposure condition हमारी है severe. Method of concrete है pumping. Degree of supervision good. Type of aggregate crushed angular. Maximum cement content 450 kg per meter cube. एंड केमिकल एडमिक्सचर यूज्ड इज सुपर प्लास्टिसाइजर. दोस्तों, इन डेटा की मदद से अब हम कंक्रीट मिक्स डिजाइन को स्टार्ट करेंगे. इसके अलावा हमारे पास हमारे मटेरियल की टेस्ट डेटा भी होनी चाहिए, यानी हमारे मटेरियल जो हम यूज करने वाले हैं उसका स्पेसिफिक ग्रेविटी क्या है. फॉर एग्जांपल, स्पेसिफिक ग्रेविटी ऑफ सीमेंट 3.15 है, स्पेसिफिक ग्रेविटी ऑफ 20 mm 2.74 है, specific gravity of 10 mm 2.70 है, specific gravity of sand 2.70 है, specific gravity of admixture 1.07 है, and specific gravity of water is 1. So इन सब डेटा की मदद से हम concrete mix design स्टार्ट कर सकते हैं. और जैसा कि मैंने आपको बताया, we have divided concrete mix design in 6 simple steps. So let's get started. The first step of mix design is target mean strength. So let's get started. Step number 1 is target mean strength. Target mean strength, the formula for target mean strength is F dash CK is equal to FCK plus 1.65S, where F dash CK is target mean compressive strength, FCK is characteristic compressive strength, S is standard deviation. Now, how do we determine the value of S? As per IS 10262-2019 table 2, standard deviation S is equal to 5. So let's go to the IS 10262-2019 table number 2. Friends, you can see table number 2. In table number 2, the assumed standard deviation for different grade of concrete is given. For M10 and M15, standard deviation is 3.5. For M20 and 25, standard deviation is 4. And for grade M30 to M60, standard deviation is 5. So here we will consider standard deviation as 5. Considering standard deviation as 5, we will put the value of S in the given formulation, where FCK is 30 plus 1.65 into S, where S is 5. So when we do calculation of this, we get final answer 38.25. Since this calculation is done in the Excel format, I have set the formulas for it so that you get the direct answer. If you have any queries regarding this, please comment me so that I will explain that part in detail. So target mean strength for M30 grade of concrete comes 38.25 Newton per mm square. Now moving on to step number 2, that is water cement ratio. Friends, from table number 5 of IS 456, maximum water cement ratio is 0.45. Now let's move to table number 5 of IS 456 so that we understand it in a more easy way. Friends, you can see this table number 5, minimum cement content, maximum water cement ratio and minimum grade of concrete of different exposure with normal weight aggregates of 20 mm nominal maximum size. Friends, in this table you can see what can be the minimum cement content, what can be the maximum water cement ratio, and what can be the minimum grade of concrete. Since our exposure condition is severe, and if we go in the line of severe and see the minimum cement content required for severe condition is 320 kg. So the minimum cement required for severe condition is 320 kg, and the maximum water cement is 0.45. Means our water cement ratio cannot go more than 0.45, and our cement cannot be less than 320 kg per meter cube. So let's move to the calculation again. Also refer figure 1 of IS 10262/2019. So let's go to figure 1. In this figure you can see that the x-axis has free water cement ratio data and y-axis has 28 days compressive strength of concrete. Now we have achieved a target mean strength of 38.25, which comes around here. And if we go straight line and interact with curve 2 and go down to the water cement ratio, our water cement ratio comes between 0.4 and 0.45, so we can consider this as 0.42. Now your question is, why do we take curve 2 and why not curve 1 and why not curve 3? Friends, curve 1 is for 33 grade, curve 2 is for 43 grade, and curve 3 is for 53 grade. We are using OPC 43 grade, that's why we will deal with curve 2. So 38 intersects with curve 2 here, and when we go down we can see that our water cement ratio lies between 0.4 to 0.45, that is 0.42. So we'll consider water cement ratio of 0.42. And since 0.42 is less than 0.45, that means it is okay. Now moving on to step number 3, that is water content. Friends, from table 4 of IS 10262, maximum water content for 20 mm aggregate is 186 for 50 mm slum. But the slum required to us is 125 mm, that is 75 mm more. So now as per IS 10262, for the desired workability other than 50 mm slum, the required water content may be increased or decreased by about 3% for each increase or decrease of 25 mm slum, or may be established by the trial. Means as per IS 10262, for every 25 mm water is increased, so our total increase will be 9%. So the answer will be 186 plus 9% of 186, that is 203. Now as we are using super plasticizer, the water content is reduced by 22%. Now the question is, why 22%? So let me take you to table. As per IS 10262, the water calculated can be reduced by the use of chemical admixture conforming to IS 9103. Water reducing admixture or super plasticizing admixture usually decreases water content by 5 to 10% and 20 to 30% and above respectively at appropriate doses. It means कि अगर हम सुपर प्लास्टिसाइजर यूज करते हैं तो हम 20 से 20 to 30% water reduction कर सकते हैं. So we have decided 22% water reduction. So now our final water content will be 203 minus 22% of 203, that is 158. Now step number 4 is calculation of cement content. दोस्तों ऑलरेडी हमारे पास वाटर सीमेंट रेशियो है 0.43 और वाटर कंटेंट भी हमारे पास है 158 kg पर मीटर क्यूब. ना हमको सीमेंट फाइंड करना है, तो वो हमको पता है वाटर सीमेंट रेशियो इज 0.42. सो वाटर डिवाइड बाय वाटर सीमेंट रेशियो इज इक्वल टू सीमेंट. सो फाइनली विल गेट सीमेंट, द वैल्यू ऑफ सीमेंट इज 376 kg per meter cube. Now as per IS 456 table number 5, 376 is greater than 320 kg per meter cube. That means it is okay, it is accepted. So our final cement content is 376. Now moving to step number 5, that is calculation of proportion of aggregates. Friends, from table number 5 of IS 102/62/2019, volume of coarse aggregate corresponding to 20 mm coarse aggregate and fine aggregate of zone 2 for water cement ratio of 0.5, the volume of coarse aggregate is 0.62. Coarse aggregate to be increased or decreased at the rate of plus or minus 0.01 for every plus or minus 0.05 change in water cement ratio. Therefore corrected proportion of volume of coarse aggregate for water cement ratio 0.42 is 0.63. Now how is this 0.63? Now I will explain you the calculation of 0.63. See, at water cement ratio of 0.5, when the water cement ratio is 0.5 and the zone of sand is zone 2, your volume of coarse aggregate is 0.62. Now moving to table number 5. Friends, this is table number 5. Volume of coarse aggregate per unit volume of total aggregate of different zones of fine aggregate for water cement ratio of 0.5. Maximum size of aggregate is 20 mm. If you go in the line of 20 mm for zone 2, the volume of coarse aggregate is 0.62. So now our original water cement ratio is 0.42. So from 0.50, if we minus 0.42, we get 0.08. So for every 0.05 change in water cement, we need to increase the aggregate by 0.01. Therefore, our final volume of coarse aggregate will be 0.63. Friends, since the method of concrete is pumpable concrete, during pumpable concrete, coarse aggregate can be reduced by 10%. So volume of coarse aggregate will be 0.63 minus 10% of 0.60, that is 0.549. Now volume of fine aggregate will be 1 minus volume of coarse aggregate, that is 0.549, which is equal to 0.451. So here we complete the calculation of proportion of aggregates, that is volume of coarse aggregate and volume of fine aggregate. Now moving to the final step, that is mix calculation. Now we'll find the mix calculation for 1 meter cube of concrete. So volume of concrete is 1 m cube. Volume of cement is equal to mass of cement divided by specific gravity of cement into 1 by 1000. Mass of cement is already given. Specific gravity of cement is also given. By putting these value, we get the mass of cement. Similarly, volume of water. Similarly, volume of admixture. Now in volume of admixture, how do we take the mass of admixture? In mass of admixture, you need to take 0.75% the weight of cement. That is, weight of cement is 376 kg. So 0.75% of 376 will give answer of 2.82 kg per meter cube. Friends, dosage depends on your workability requirement. So I have taken 0.75. It depends on your dosage requirement, whether you can also take 0.85, you can take 0.9, you can take 1%. It depends on your workability requirement. Similarly, volume of all in aggregate, that is coarse aggregate plus fine aggregate. So 1 minus volume of cement, volume of water and volume of admixture, which gives you answer of 0.7145 meter cube. Now this is the total volume of all in aggregate, that is coarse aggregate and fine aggregate. But how much is the mass of coarse aggregate? So to find the mass of coarse aggregate, the formula is F, that is volume of all in aggregate into volume of coarse aggregate into specific gravity of coarse aggregate, that is 20 mm into 1000. So F is already given, that is 0.715, and volume of coarse aggregate is already we have searched, that is 0.549, and specific gravity of 20 mm is 2.74, which is also given into 1000, which gives you an answer of 1074.04 kg. Similarly, the mass of fine aggregate can be found in the same manner, where F is volume of all in aggregate, that is 0.714 into volume of fine aggregate, that is 0.451 into specific gravity, that is 2.70 into 1000, that, and our final answer is 86943 kg, that is mass of fine aggregate. Now the final proportion derived by doing all this calculation for 1 m cube is cement is 376 kg per meter cube, free water is 158 kg per meter cube, fine aggregate is 869 kg per meter cube, coarse aggregate is 1074 kg per meter cube. Now this coarse aggregate can be further divided into two, that is 20 mm we can take 60% and 10 mm we can take 40%, and last the super plasticizer is 2.82 kg, that is 0.75% of the cement. Our final density comes to 2480. So friends, this is how M30 grade mix design calculation is done using IS code 10262-2019 and IS 456-2000. Friends, I have tried my best to explain you in a simple manner, but still if you have any doubts, please comment me so that I can explain you more clearly. Thanks.